Paramagnetic nature. Most of the transition elements are paramagnetic due to the presence of unpaired electrons in them. The spin-only magnetic moment is given by the relation mu equal to root n into n plus 2 Bohr magneton. So any element, atom or ion or an D block element in its compound, it will be paramagnetic and colored only if it contains at least one or more unpaired electrons. This is the basic condition. And we can calculate this magnetic moment by using the formula mu equal to square root of n into n plus 2 Bohr magneton. This is by considering only spin magnetic moment. If you consider orbital magnetic moment, then root L into L plus 2. What do you mean L here? L is nothing but azimuthal quantum number. We can calculate magnetic moment of scandium now. See, atomic number 21 means configuration of scandium argon followed by 4s2 and 3d1. So total number of unpaired electron here it is 1. So put value of n within this formula. This is 1 into 1 plus 2 root 3. Root 3 means it is very near to root 4. No, so answer should be less than 2. Root 4 its square root it's 2. So 1.7 something, 1.73 Bohr magneton. This is the magnetic moment value for scandium. If I consider Sc2 plus, here argon configuration followed by 4s0, 3d0, 3d1. So n equal to 1, therefore mu value once again same 1.73 Bohr magneton. If I consider Sc plus 3 does not contain any unpaired electron, argon configuration 4s0, 3d0, therefore n equal to 0, it means that mu equal to 0, diamagnetic. Therefore, any compound related to Sc3 plus, for example, ScCl3, it is diamagnetic as well as colorless, whereas ScCl2, it should be paramagnetic and colored. Like this, we can calculate magnetic moment of any kind of transition metal atom or ion or that atom in any kind of compound. For example, if you consider copper sulfate, CuSO4, here oxidation number of copper is +2. It means that configuration for copper is argon followed by 4s0 and 3d9. So total number of unpaired electron, it is 10 minus d9 electron. So only one unpaired electron, magnetic moment value, it is somewhat 1.73, like that. Next, the first series transition metal oxides are generally formed by reaction of metal with oxygen at very high temperature. So scandium oxide or manganese oxide or iron oxide, even copper oxide or zinc oxide, it is formed only at high temperature, not at room temperature easily. These oxides may be acidic, basic or amphoteric. So lower oxidation state, a metal atom or ion in its lower oxidation state always basic in nature, and higher oxidation state acidic in nature. Moderate range means or intermediate range means always amphoteric in nature. These oxide dissolves in acids and bases to form oxometallic salt. For example, potassium dichromate, potassium chromate, potassium permanganate, etc. These are some examples for oxometallic compounds.